Hey guys, morning. Oh, Lenise is here. Morning, Lenise. Morning, Lucas. Morning, Teddy. Morning, Katrin. Morning, Kathleen. You, Lee. Hello, hello. All right, yeah, people are here. Sorry, Lenise. Sorry if I was so loud. My presence was known in a Pinot house. Sorry that was so loud at 7:54. That's awful. Oh, sorry, Kathleen, if I called you Lenise. I don't remember that. My bad. I'm just eating a little yogurt. We got 5 minutes till class. Y'all can mute me. All right, 2 more minutes. The whole crew. Benjamin, when was your last flight? Oh. All right, we're at 8 o'clock. Let's do this. Just gonna do the attendance here. So all right, we have talked a little bit more than normal today, so I'll just have to scroll back up through those. Just going by what I saw. I saw Jared, I saw Sam, did see Teddy, saw Crystal, saw Yuli, saw Kathleen, saw Katrin. I don't know if I was looking away when Maddie said something. I believe I did not. Saw SJ, saw Sade, saw Zion. Awesome. Sorry, just doing last couple people here. Saw Lucas, saw Erica, and I think we are good. Just going back up because I don't know. There's so many K's. I just forget if I'd seen Kendra in here. I don't actually think I did. By so many K's, I mean Kathleen has responded a bajillion times. Yeah, I would say no Kendra just yet. Okay. I have Larissa is having trouble getting into the thing, so just give me a minute. I just gotta link her to like an old lesson or something like that. And then we'll get started. I don't know if you guys had any questions from the... we didn't really do much homework, and I'm sorry. I know a lot of you guys lost your connection last week. When we, I don't know, the power went out in Beamsville or the internet went out in Beamsville on Friday. So we missed a bit of that lesson at the end there. So hopefully you had a chance to look at that. But anyways, I'm just going to quickly see here. Grade 9. Let's see if you had any questions about those while I'm looking this up. especially those scale ones, because that's an important skill. Okay, sorry about that. I think we're all sorted now. Then oh, hey Kendra. I am here, all caps. Okay. And then I guess, I'm not sure if I saw Maddie yet, did I? Let me just quickly, oops. I would say no. Okay. All right, let's share my screen then so we can go and take a look at this stuff. I had you guys, I think this is the part where some of us got cut out on, but I was asking you to look through this here and try some of the other ones. So I don't know if you guys had a chance to do that, but basically try to make a scale using this data, right? And we talked about there's the range, so it's like how far apart is your smallest to biggest number, because that's how far I know I'm going to have. And then you count your number of boxes, and you basically just say, okay, like the range is how many numbers I need to go, and the scale, the little, like how many, how many boxes, if you divide that by how many boxes you have, that'll tell you how far each little tick should be. So it's the total amount of numbers that you have in your scale. So in this scale, there's, 7, right? There's 7 things that we need to have on our scale. And so to make sure, how do we know what number to go up by? Well, you take that 7 and you divide it by the number of boxes. Well, here, it was less than 1, so we could just go up by 1. That was easy. And then we tried other ones where we tried over here. Well, the range is like 117, right? It's 117. And so if we divide 117 by the 7 boxes that are on our range here, there's 7 that goes up. Then in that case, right, you're like, oh, okay, well, every tick needs to be 16.71, but there was no point in making it 16.71, so we round up, right? You always round it up to a nice number like this. So that's a super useful skill that we should definitely practice. So I just need to, again, adjust the attendance. Okay, sorry about that. I'm not sure. Did anyone get a minute to try these? Did anyone have any questions about how you do this? Or I guess I don't think I really assigned some. I think I highlighted number 3 because I wanted you guys to do number 3 from yesterday, at the very least. Yesterday by Friday, I mean. Did anyone have any questions about 3 or any of those distance time graphs, or did you want me to try and do another one for you right now for the scale bit? Sorry, not distance time, but the scale. We're doing distance time today. Or were you guys happy with those? What do you think? Either give me like a thumbs up, you're good, Or can you do like one more of the scale or something? Because I do know some people miss that part of the lesson live. Hopefully you got a chance to go back and look, but if not, no biggie. Okay, some people want to see that scale. Okay. So let's do this. I'm going to erase this nastiness because this has gotten a bit ugly on us. Okay. Just to make it a little bit cleaner, right? All right. So you follow your steps. And I'll probably do like this 50-meter dash one or something like that, okay? Or even I'll do one of these on like part C or D because we didn't do those ones, and then I'll do this one on part A or whatever, doesn't matter. So the steps are determine the range and values. So for the X's and the Y's, you figure out what the difference is between the points. So let's do both of them again. I'll just remind you. So here you look at your X values and you look at your Y values, same thing over here, right? This is a totally separate, this is like another question, right? These are your X values, things you'd put along the X axis, you put like first, second, third, you know, that kind of thing, right? So you could just think of them as numbers, even though they're words, you could think of them as numbers. And then our winning time as well. So let's go ahead and find the range of all of these. So basically remember to find the range. You can look up here. It's really like max being like your biggest number, and you subtract your min, which is minimum, meaning your smallest number. So I see my max here, and my min is here. That's my smallest number. I could also do that over here in these values, right? I could look, and this would be my max, and then I look at my smallest number, and it looks to be 192. We talked about how it doesn't always have to be like perfectly in order here. So to find my range for these ones, right, I would take 2007 and subtract 2000, which tells me that my range is equal to 7. That's great. And then over here, I would say that we take my max, so 309, and subtract 192, and my range will be equal to, honestly, I should be able to do that in my head, but I think it's a Monday morning, and I don't want to mess that up. If we went back to be 83, oh, frig, I don't know. Let's just do this. No, it wouldn't be anything with 83. I don't know what my math was doing there, but I was subtracting them in reverse order. 309 minus 192, and yes, I'm using a phone calculator because I'm disgusting. That'd be 117. So we've got 7 and 117 as our range, but that's not the scale. You don't go up by 7. You don't go up by 117. That's like the smallest to the biggest number, and so we need to figure out like how many spaces do we actually have, because you don't go up by 117. That'd just be 1. So how many spaces do we have and how many do we need, kind of thing. So, oops, there's a little red tick there. So remember, in terms of my range, my Y values, they will go here, and these numbers, they'll go along the X-axis. Now, clearly, I can put all of these on here, so I don't really have to do that math, right? I can just go up by 1. But what I can do, and I'm going to count them just because we're going to look at this in a second. Anyways, how many boxes do I have? Well, maybe you'll give yourself a little tick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 boxes. Okay, 19 boxes. I should call them ticks. Boxes is kind of weird, but anyways. And then here, how many? 1, 2, 3, 4, 5, 6, 7 boxes here. Okay, so I need basically to fit these two scales, fit this amount of data, a range of 7 on 19 boxes. Well, that's going to be easy, right? I know I can just go up by the right amount. But what's my formula? Well, basically, I just take my range, and I divide it by the number of boxes. So my range here for my X values, right? The range is 7. So I need to have 7 stretched out over all of this. So we just go 7 divided by 19. And I think that was equal to like 0.3 or something. Let's just quickly. Calculator, where are you, my friend? Uh, 0.36. So basically, let's call it 0.4 or whatever. But you need to take this and you need to round up. Remember I said you always round up to a nice number. Like a nice number. Don't round up to 0.4 even. That's not really that nice, right? You wouldn't like, so what do we start at, right? We start at 2,000. So you wouldn't go along here. You wouldn't go 2,000 and then 2,000.4. And then that doesn't make any sense, right? So just round up to a nice number, especially when you're dealing with years and things like that. So on there, we're going to round up, and I'm going to say round up to 1. What the heck are you guys talking about in the chat? So it'd be 2000, right? 2001, 2002, anyways, 2003. And basically this tells me, right, how much I'm going up by each time. Now that one's pretty easy. Let's do the y-axis. I know our range is 117 and I only have 7 boxes, right? So I need to take 117 and fit it over 7 boxes. So we need to take your 117 here, divide it by 7. So my range divided by how much it is. And if I do that, oops, that's 1,017. 1 second. 117, that's delete. I struggled this morning, team. I get 16.7. And I know I've already done this one with you guys. I just want to explain the steps again for those people that were missing. I should have actually done a different one. I don't know why I did this one again, sorry. 117 divided by 7 is 16.7. Now again, you want to round up to a nice number. You want to go up by not 16.7, not even 17, because going up by 17 is really weird. So just round up to like 20. And there's no specific rule. Technically, you wouldn't be wrong to go up by 17. It would work. You could start at, what's our minimum? 192. You could go up by 17 every time, but it's just like, who wants to count by 17s? It's like 17 and then 34. It's just not fun, right? So you want to go up by 20 or a nice number. If it was like 12, you could maybe go up to 15, but even 15 is like kind of weird. So you can really pick whatever you want as long as you round up. Just try to pick nice numbers is my suggestion. So we're rounding up to 20, and again, we are starting at 192. Now again, I would recommend that you don't actually do your squiggle and then write 192 here, because then you're going 192 and then we go up by 20, right? So it'd be 112 and then 132. Like 132, 112, why don't you just like start at 190, right? It doesn't have to start at the minimum number. I would say start at 190 and then go up by 20, because 192, I know, will fit in right here, right? At year 2000. We'll have 192, it'll be right above it. And then my next tick, right, we're going up by 20, be 210, 230, and then so on. We're going up by 20 every time. Sorry, I should move that 7 boxes. You don't have to fill the whole thing out. But then that would allow you to fit all of your numbers on that axis pretty good. Now let's do something a little different. Let's take a different shape here. Maybe let's take something like this. No, we already did that one, I think. Let's do C maybe, something like that. Okay, so we'll take this guy here, or even this one. This one's a bit ugly, isn't it? Yeah, we'll do D. Okay, so this one, still we're fitting the same data. It's like, okay, what happens if I want to take the same amount of information, this same data here, and instead of putting it on this axis, where to graph it on here, I want to graph it on this one, where the x-axis will still go up by 1. You can kind of tell, right? Because we go 2000, 2001. There's going to be at least 7 boxes. Now, maybe not exactly. Let's actually count. 1, 2, 3, 4, 5, 6, 7. Yeah, so this one would still have 2000. You don't really have to do your math on that. 2002, because I know it's going to fit. And there's not that many numbers. But here, I need to take, remember my range here is 117, right? And I need to fit 117 numbers over 1, 2, 3, 4. Let's call it 5. You can go up to the top there, right? 5 boxes. Because I think it pretty well has that full box in there. So we need to take our 117 and we need to divide it by 5 boxes this time. And so if you do that, 117 divided by 5, it's 23.4. Now, again, round up. You could round up to 30, but 30, 60, 90, 120, it just is a bit weird too. Like you can round up to 25. 25 is a pretty nice number as well. It's really whatever you want to do. 25 or 30 would be correct. Because we're actually drawing our little squiggle here, right? And starting at 190 as well, because remember our first value is 192. 190 plus another 25, plus another 20. Anyways, it'll work out good, right? 190 plus 25 is going to be 115. 115 plus another 25 is going to be 140. Plus another 25 would be 165. Plus another 25 would be sorry, what the heck is going on with my brain? I should be in the 200s. How many things did I say there was 5 again? Sorry, that was 23.4 or something like that. I can't really remember. Sorry, I should be going by 25s. I totally butchered this. 215 plus another 25. 240 plus another 25 will be 265, and then another 25 on top of that. 90. Awesome. Alrighty, let's look at oops, sorry. Dang, my computer is being really weird. Oh, you know what I just noticed as well? Because I didn't start at the bottom, which is totally possible, you see we actually don't fit all of our data on here, unless I've done a math error, but I don't think I have. 190 plus another 25, 215 plus another 25 would be 240. It's one of those things where you check your work and then you already like assume it's right. 265 be 270 plus another 90 be 290. Okay, so you see here how we actually didn't get the last tick on because to count 5 boxes, that incorporates you starting actually at the bottom here. And I always mess that up, whether you need to start there or not. Depending on how much you round up by, it won't matter. But you see here, I didn't actually get up to 309, right? I need to fit 309 on here. So actually I should have, if we take all of those numbers there, and move them down, and then just normally you just draw that squiggle in below. It's like, okay, start at 190 and then go up by 25, because that's what the rounding is really assuming that you're doing to fit all that data in. It's assuming that you're starting using that bottom tick, because we'd have 5 ticks. If we waste this whole gap in here, you're assuming there's actually only 4 boxes, so that's why we had to move that up. Oops, sorry, that got a little ugly. And then our last one there, again, we need to go up by 25, is going to be 315. And now that fits everything, right? Then we needed to go up to 309, so we fit it perfectly. Okay, let's try this data set. Let's look here at our range for each of them. So our max here looks to be 14.4. And our min looks to be, I know it goes down and then back up and all this other stuff, but that's our min. So if we do our range here, we're going to get 14.4 subtract 8.7. And I think I did that right. 14.4 minus 8.7. Yeah, so we're getting our range is equal to 5.7. Thanks, Zion. Awesome. And then over here, right, if we look, there's 1, 2, 3, 4, 5, 6 jumps. And if you do 7 minus 1, 6, right? But there's 6, a range of 6. Thank you, sir. Awesome. So again, that always assumes that you're starting at that first one. But in this case, I don't think there's any scale on here for our x-axis. If you look at the number of boxes, none of these is less than 7, right, or 6. So we could fit them in anyways. Let's try and do one where there's not going to be that many numbers. Let's take this data. We could do it anywhere, but if I look and let's put it on here, right? Something like that. Okay, so when we take that scale here, our ones along the x-axis, again, we don't have to do our math. You can just say, especially because they're words, you want to make sure they all fit. If they don't, you kind of want to cry. So first, second, third, fourth, and we could write them all, but we don't need to because it's not really part of the question. And then on here, I know that my range is really small, right? In this case here, my range is 5.7. So if I take that 5.7 and I divide it, there's a crap ton of ticks here, right? Like there's actually like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 ticks. Thank you, Zion. I need to be like totally live because Zion is like, you're giving me all the info. Thanks, buddy. 16, but you're just like a second behind me, so I see you type it and then yeah. Anyways, thanks, bud. 16 boxes. So here's the little trick, because obviously, oh, sorry, somebody's teamsing me. Obviously, I can fit 5.7 on here. No problem. Oh, looks like I'm unable to connect to chat. It's random. Hopefully you guys are good. Still there. I don't know. My thing is telling me I can't connect to the chat with you guys, so I'm not sure if I'll see your messages anymore. If that's the case, I think you should be able to still see me live. I'm just not sure that the chat is working, so maybe just Teams message me if you get. And so if you're looking, you're going up and down on your scale. 16 boxes here for our 5.7, right? So 5.7 divided by 16 is going to be equal to I get 0.35. So I'm going to round up 0.36, it says. Now, 0.36, if we're looking at that, obviously that scale doesn't make sense. And I always told you guys you want to round it to a nice number. And a nice number here would be 1. And that's totally fine. You can round up to 1. And if I'm looking, I can go, okay, well, what's my minimum number? It's at 8.7. So maybe I'd start it at 8, right? So I'd start it at 8. And then I'd go, 9, 10, 11, 12, 13. How even high do I have to go? Not that high, right? 14.4. So 14, 15. Yay! We fit it all on there. But then I have to like find, like when I'm doing my scale here, right? For like 11.6, you know, then it's like, okay, 11.6 is like halfway. It's just like we've got all this room. Why are we wasting it? So when you've got numbers that have like really small decimals, okay, like this, it's actually okay to round up, not to 1. You can round up to 1 and then you're not wrong, but you could even round up to like 0.36 to round up to a half. To a half, or 0.5, right? It's the same thing. So if I round up to a half, then instead of going, you know, along here starting at 8 and going up by 1 to 9, 10, 11, 12, I'd go up by a half. So it'd be 8.5 would be here. And then this one would be 9. And then, you know, 9.5, and this one would be 10. I'm actually going to erase that 9.5 and not put it. Even the 8.5, I don't even really need to put that. I'll put that on there just so you guys can kind of see what I'm going with, 8.5 in there. But basically, if I go up like every 2 ticks now, and that's what it's telling me I'm going to be able to do, because I can go up by a half, I round it up to a half, I'm able to now graph a lot more accurately, right? If I look at this, I see, oh, I need to graph 8.7, right? Or 13.1 even, 13.1. Well, I can look here. If this is 13 and this is 14, you know, 13.1 originally would have been so small and it would have been like really inaccurate. But now I can be a little bit more accurate because I've chosen a better scale. I'm just going to refresh the YouTube stream just to see if that helps me reconnect to chat with you guys. Okay, I'm back. I can see your chat again. Okay. Zion, you're so edgy when I'm gone, man. Using those real bad words. Math sucks. Thank you for correcting that to stinks. It's super smelly. It's a smelly boy. Okay, so did you guys see? I don't know. I think you guys could see what I did there, but you saw, like Zion said, actually, now I can see what he's talking about there. You know, you can just go up by a half, right? It'll be good. That's how you know that it'll work like that, because you've done the math. You've taken your range, how many values you need to have, and you divide it by the number of boxes. And you could do that for any of these. You know, I probably wouldn't be able to do that here, right? Down here, if I took this, and let's do that with the same data, but don't start at 0.5. Yeah, exactly, Zion. It kind of, yeah, you don't really want to start at a half. You want to start at like a whole number or something like that. But if we look, and I'm like, okay, I want to take that data we did there. Let's erase. Oops. Whoa, that was a little flashy. Let's take that same thing and let's just do the range here. So here we only have, right, you got your 1, 2, 3, 4, 5 ticks. 5 boxes. And so if we take that same range, right, that 5.7 here, and we divide it by 5, well, it's going to be bigger than 1, right? 5.7 divided by 5 is going to be 1.14. So I can't even go up by 1, that tells me, right? If I started down here, right, and if I start at like 8, or even 8.7, right, 8, and I go up by 1, 9, 10, 11, 12, 13. Oh shoot, that's not going to fit, right? Because we know that we needed to get 14.4 on there. It's not going to work. We didn't get enough things. And so just like Zion said, you remember you round up to the next nice number. So we got to round up from 1.14 to 2. round up to 2. And so instead of going 8, 9, 10, 11, 12, 13, we have to go 8, 10, 12, 14, 6. And you're going to waste some of the scale, right? And you got 10 boxes. Awesome. Thanks, Zion. I see that now. I'm good. Back to being live. And yeah, because you have 10 boxes, like Zion says, we only need to have a range of 6, right? Well, you're going to be able to fit them fine. So we don't even have to divide there. You can just know that you wouldn't have to divide. Sorry, I didn't close this bracket. It looks a little ugly. So does that make a little more sense, guys? Is there some way you can practice this 100%? Basically, for the rest of this unit and the rest of the time you have to graph anything. It's only ever really helpful if you have like a specific thing. Like normally this happens on a test where the teacher or whoever it is, when you guys have ASO next year, they'll give you like some sort of word problem and they'll be like, okay, make a scatter plot of the data. This could happen in physics or geography or stuff like that too, right? So it's just a useful skill to have no matter when you graph anything. Sometimes people give you the box, right? If they didn't give you the box, well then you guys could just go, right? You could go up to your view, and you could go to your rule lines and make this, and you could draw whatever scale you wanted. You could make the thing like infinitely large, so that way you could have like go up by 0.01 or something stupid small, or always go up by 1 because you like to do that. It just like when you have like thousands and big numbers, sometimes it just doesn't make any sense. And this skill that I've taught you is really for what if somebody gives you the box already and you need to try and make the data that you have fit in the box. Or you draw your own axes and you gave yourself this much room, you only have that much room on paper, or in this case, it doesn't really matter, but you don't want to draw like the world's largest graphs. You've drawn, your X and Y axis here. Maybe I go like this, oops, and you're going something like this, and you're like, okay, sweet. Well, I've just drawn this. I don't want to make it any bigger than this, so I know my range has 1, 2, 3, 4, 5, 6 boxes on here, right? My Y has 6 boxes, and then my X has blah, blah, blah. And then you take the data that you have and you make it fit in the thing that you just drew. But again, this skill is more useful because you could, if it didn't fit here, right? You could always click this thing and just be like, okay, it didn't fit. I'll just fix that. I'll just make it fit, right? I'll just keep going up until it fits. Or it's like, oh, you have too many? All right, let's go down until, it's the right number. So that one is not really that important. This skill that we just learned is not that important for your own drawn ones. It's more important for what happens if you have to make the data fit on a specific sized grid. And if we're all good with that, we'll maybe move on. Maybe give me a thumbs up. But definitely if you want more practice specifically like that. Okay, sweet. No problem, Sam. How did I do what, Ben? The drawing of the axes? You just take it. So the grid, I don't know what part you're saying, how the frick did you do, but you'd get the grid on, right? You go to view, rule lines, and then you can choose any grid you want, any size. And then I don't know what else you're talking about, but maybe in the XY axis, you go draw, and then you go shapes, and then you can choose anything, right? And you just drag it, make it whatever size you want. You can even go backwards. Yeah, I don't know why you do that, but you could. All right, we got a skedaddle. So if we look at your distance time graphs, okay, we've learned about slope, and you guys have done a pretty good job. You were able to make the connection like a while ago. Remember when we talked about the car losing gas? And it was like the number of kilometers that they drove, and then, you know, the gas was going down. And so you guys were able to compare gas mileage, right? The one car had a steeper slope, and actually it worked out that it was the electric car. Remember, it was like more negative. Sorry, which way are you guys? I need to be going like this, right? It was steeper negative. And so it was losing gas faster, right? It's like liters per kilometer was significantly higher than the other cars. It was dropping faster. So you guys obviously know that the steeper the slope, the higher like the rate of change, right? And so that was a way that you guys could compare things. And if you remember back to that little chapter 3 task, we're already at chapter 6 and we're still doing lines, so we're going crazy, right? But that slope was all about, right? If you think back to that graph there, these were like your liters, and here was like the kilometers that you drove. And so it was like the change in y over the change in x. Remember, this is your y, really, and this is your x, right? And it's rise over run. And so it was always about liters per kilometer. How many liters does it use per kilometer? And then today, when we're going to look at these distance time graphs, instead of it being a liters and a kilometer, you rethink that. And if I think about distance and time, well, time is always along the x-axis, right? Time is always along this x-axis here. And then distance, right? Distance or displacement, they're two different things. We'll talk about that in a second. But anyways, similar. Distance would be on your y-axis. So if I think about the change in y over the change in x, right? Or the rise over the run, that would be a distance over time. And what are some typical units of that? Well, distance could be in kilometers, right? And time could be in hours. And so what would that look like? Well, that would be like kilometers per hour. Or it could be like the distance was in meters and the time was in seconds, right? And then your distance could have been meters and time was in meters per second, kilometers per hour. When you think about meters per second and kilometers per hour, what do you think of? What is that actually talking about? As I take a bite of strawberry and yogurt. Thanks, Sambo. Speed. 100%. Yeah, rise of a run or whatever, but in general, right, the slope is how fast the car is going. So if I drew you a graph right now, I don't know why that always pops up, where, let's think about this, right? This is like, you know, the car starts down here. I'm going to draw a couple things on here. If the car started, right, it's drove no kilometers and the time is 0. Well, at 1 second, right, at 1 second, I don't know why I need to write S down there. If a first car, right, if this is like 5 meters and this is like 10 meters, if it has a slope that goes to here, right, in that line, well, that's pretty steep, right? That means that it goes up, sorry, where's my mouse? Up 5 kilometers per 1 second. That's pretty steep. But what if instead in that 1 second, sorry, my 1 is underneath there. I think you guys can kind of see that. What if instead it goes to 5? No, actually it goes that same 1 second. There's a different car. It's able to cover 10 meters, right? That means it's faster. In 1 second, if it only did 5, you can see that that slope, right, is not that steep. But then the steeper this is here, right, the faster it went because it was able to go 10 kilometers in 1 second instead of just 5. And so when we're talking about slope, the steeper something is in terms of your distance and your time, the faster it's moving, okay? If I had something where it's just flat like this, right? And I'm gonna make a little summary of this, so don't feel like you have to write this down. Okay, sorry, I should have said that at the very start. But I'm gonna, whoa. I'm gonna make a little summary of this, and that's what the note's for. I just thought this would be a good explanation. If instead at like 1 second, he like actually didn't travel anywhere, he stayed on the couch, like most of us in quarantine. Well, then I look at my ruler and go, oh, well, that slope should be flat. It's just my line's not flat, right? It just hasn't gone anywhere. And what's that? Well, that means our speed is 0, right? It's up 0 over 1. Okay, 0 over 1 is 0, right? Our speed is 0. Over here, it was like up 5 over 1, so it's 5 meters per second, right? I was gonna say kilometers, but I talked about meters there. Or up here, the slope is our speed. So that's what it's all about. So let's actually just summarize that. So distance and time. These are like a classic graph in science, in math, and they're really cool for us because we can start to think more about slope and what it actually means and what happens when that slope is changing, right? Or when it's flat. So thinking about that. So when we talk about our distance time, obviously you can look at like, the distance. You can look at the time, and you can look at the speed. You can also look at other things, and we'll look at that in a second. And this is more like a grade. Sadie, how is yours already filled out? Did I send you guys the wrong one? Oh, that's awkward. I sent you my little answer thing. Lucky you guys. Yeah, well, I would say that I'm gonna have a hard time convincing you to erase that and rewrite it because you might not see the point in that. Well then let's just move through this a little bit more quickly, but let me explain it. You don't have to copy down. But let me kind of explain as we go, okay? That way you can read, at least, right? Because if I just sent this to you guys and was like, all right, now go know it, I think it'd be harder. So anyways, you're welcome, or I'm sorry. I'm not sure which one to say. So basically time, it says usually, but think always, the independent variable, you guys already had that down, so I don't really need to spend a whole lot of time. Independent variable, so therefore it's on the x-axis, right? Whereas your distance, is your dependent variable, and that would be on your y-axis. Okay, so the speed was the slope, right? So depending on what your slope is, that provides you information about the speed, which we just talked about, right? So the steeper the line or the curve, just like we had over here, right? If it's able to do, right, in 1 second, 5 kilometers, or 5 meters, whatever you want to talk about. I don't know. I should just pick one unit. Let's just erase the kilometers and the hours. So in 1 second, if it does 5 meters, that's pretty good. But if it's able to do 10, right, that's a lot faster. To get 1 second to get 10, that's way faster. So the steeper it is, the faster the speed. You could say greater, the faster. And then the less steep the line or curve is, the slower the speed, right? So the faster, you guys already have this. And I might have used I don't remember what I used last year in that little answer key that I gave you guys there. But the greater, and this could be lower, I don't know. Either way, faster means steeper, slower is less steep. If you have a horizontal line, right? And it's just not moving at all, like this one here, right? And this is how we combine these things. But if the line is completely horizontal, that means that time is going on, but the distance is not changing, right? Time is happening, but distance is not. And normally when I'm in a classroom, I walk around and do a little demonstration with you guys, but it's hard when we're all in front of a computer here. So this means that the object would have been stopped. So then the speed is 0. Okay, so linear relationships mean, right, if you're looking here, this means, right, if I look, the slope is always the same. This is linear, right? Straight line right here, at least from here to here, okay? So from here to here, our speed is always the same, right? We're going down 1, 2, 3, 4 over 3, right? So it goes down 4 meters every 3 seconds. And that's a pretty constant speed. Over those 3 seconds, it has the exact same speed. It's like always going, well, I should go down, like down 4 meters every 3 seconds, right? This could be like a balloon with a hole in it, something like that. I don't know. So it's going down 4 meters every 3 seconds for those 3 seconds. Boom, 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 boom. Constant. And then for some reason, this balloon, like they put tape on it. So it just stops. Okay. So this is a constant speed. However, there is like almost nothing in the world that can be going like down 4 meters every 3 seconds. We're talking about balloons here, Sam. That's why you tape it. I don't know. It's just like a... Like think about in your car, okay? Let's pretend your car is going -4 meters. Maybe it's going backwards, right? -4 meters per 3 seconds. So it's going like back, 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 or like you're walking backwards, right? And then you stop. Well, even for me, like it's very hard to make your speed something and then just like totally stop. There's definitely some change in there, right? It's hard to go really fast to complete zero. Normally you slow down, your speed changes over that slow period, right? Not in everything. There's some things that just, sorry, that was really loud. But there's some things that can just completely stop. But in a lot of cases, especially with human error involved, there's like that bit of acceleration period, right? When you think about your car, you don't just go like zero and then get on the highway and go 100 kilometers an hour, right? You start and you go 0, 10, 15, 20, 20. Anyways, you get faster and faster, right? And that change in speed causes it to not be a solid line here, but it looks like, because slope, we talked about slope as speed, right? So if I look at my ruler, this slope here, which is speed, is always the same from here to here, right? It's the same speed. It's always the same speed. And then here I look, oh, I see a flat line. Okay, so from 3 to 6 seconds, it's completely stopped, right? It's fine, it's always the same. But then here, you know, if I was to look at any point on this line right here, right? Okay, so maybe it's like that steep. And then I look, and as I go along, it looks like this line becomes steeper and steeper and steeper as we go. So basically what that would mean is, right, we stopped, dead stop, flat is dead stop, and then we're slowly, as I turn this ruler, becoming steeper and steeper. So it's getting, we're going backwards. I know distance is going down here. This could be like you falling off a cliff or something like that. That's a terrible analogy. But if I was to like, you know, slide down, like let's pretend I'm falling. So I'm sliding down this cliff and then I hit a rock. And then it's just like, boom, stopped, like instantly stopped. It's not like, oh, slowly stop. No, it's like, okay, we were, you know, going down, 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 boom, stop, right? And then, okay, we're going along, and we're all stopped, right? We're not moving anywhere, time is stopped. It's like, oh no, I'm falling, and then we're slowly getting faster as we go, and down like that. So there's acceleration there. The speed is changing, oopsies, changing. Or you could say this is, if you guys have taken science or even just took in life before, that's acceleration. Why not just someone runs out of gas? Like, I don't know, Ben. I'm trying to like make analogies here, dude. So describe the motion that's happening here. So basically, from here to here, from 0 to 3 seconds, the speed is a constant -4 over 3 meters per second, or you could say negative 4 meters per 3 seconds. That'd be another way of doing that. And then from 3 to, what is it, 6 seconds? From 3 to 6 seconds, the car is stopped, or the speed is stopped, or the object, let's just say object, we'll keep it general, because this graph doesn't have a title, and it doesn't have labels on the X and Y axis, so basically, this person is the worst. And you could give it a title, whatever. The object is stopped. And then from our final 2 seconds, right? Let's take another color here. Green, because why not? Oopsies. Green. Okay, so what's happening is it's getting steeper, right? It started flat, and it looks to be getting steeper. So from 6 to 8 seconds, the object is, you could say, accelerating or picking up speed. And getting faster. Oh, sorry, you can't see. The object is zooming. Okay, so we're just gonna do this last example, and then we'll be done, skis, and you guys can just try like 1 or 2 of these on your own. But this is like, okay, there'd be 2 types of questions. You describe it here. Well, I guess you guys have the answers to this, so I don't know why I'm like slowly explaining things. Sorry, I don't know why I'm giving you guys like so much time to do that. That sucks. Yeah, it kind of sucks you guys have the answers to this. Probably has caused a few people to tune out. Anyways, I'll just do this one quickly then, because I do know that you guys do have the answers. So let's just actually go to where I have the answers here. And I've already drawn it in here. So basically, if we're looking here, right, let's just talk. So your student leaves home, right? Basically, we're drawing a distance time graph. So this is the distance from their house, okay? So this is a good one because we had to kind of decide, you know, what our scale was and stuff like that. So basically what happens, you got to kind of look through these. These are super difficult for a lot of people because you have to kind of read the whole story first and go back and think about what's happening here. So student leaves home, they're walking at a steady pace. When I see steady pace, that means linear. This is going to be hard for a lot of us, I think, to kind of get the picture on these. And I know it looks easy when you're just looking at this question in front of you, but when you're trying to actually practice these and do it and dissect the question, that's why I wish you guys didn't have the answers to this, because then we could slowly dissect it together and you could see where everything comes from. So because it's a steady pace, that means it's going to be linear. But anyways, let's not start that yet because we don't know how far, right? We just know that it's going to be linear. So after 4 minutes, he begins to slow down. So I know it's going to be linear up until 4 minutes. So the journey so far, right, I know it's at least going to be 4 minutes. So this is me, and I've done my work over here. I'm trying to figure out, right, what my range is going to be in terms of total minutes on the x-axis here. So as I'm going, okay, I know it's going to be 4 minutes, and then slows down, begins to slow down, and then stops for 1 minute, okay? So I know that it's at least stopping for a minute here, right? Begins to slow down and then stops for 1 minute to mail letter in a mailbox. He then turns around and runs home for a constant speed of 2 minutes, right? So I know that there's going to be 2 minutes where he runs home. So the last little bit in here that I've added, this little +1, is this question actually had a flaw, and I remembered that because it doesn't say after 4 minutes he begins to slow down and then stops. So it doesn't tell you how long he slows down for. So I'm just going to say 1 minute, and that's why I added that little 1 there on the end. Normally I'd have to give you how long that would happen for, right? It wasn't descriptive enough. I told you how long he stops for, but it says, he walks at a steady pace for 4 minutes, and after 4 minutes he begins to slow down, and then he stops for a minute. So it doesn't tell us about the slowing down bit, right? That's slowing down. It needed a time. And so that would have to be, let's just say 1 minute in there just to keep our lives easier. So I know that in total it would be 4, right? That first 4 minutes, the 1 minute of slowing down, the 1 minute where he stops, and then the 2 minutes for like that constant like run back home. So what is this going to look like? I do know that the mailbox is 500 meters from his house. So when he gets there at the very end, right, it's going to be 500 meters away, and that's where he's going to be stopped at 500 meters. And so I've decided, right, again, there's not enough information in this question here, and that's one unfortunate thing. But I've said, okay, for that first 4 minutes, he ran 450 meters of the way there. Okay, or is he walking? I can't even remember. Yeah, he walks. So he walks. He's going to check his mailbox. And so then he's walked for that 450 meters, and I had to kind of make that number up because it didn't tell me. It just tells me that it stops at the mailbox, which is 500 meters away. And I assume he's going to slow down for that last 50 meters. And the important piece here is that you draw, that being more of like not a straight line and more of an arc. It can't be linear. It was this speed and this steepness. Sorry, it should be more like this for you guys to see it. But then it's going to slow down towards a stop. You don't just go up, slow down, then stop, right? That's what we need. Here it looks unrealistic because it's like he was stopped at the mailbox and then there was no acceleration. It was like something out of a cartoon, like, Roadrunner, where he goes and he just shoots off, right? At that crazy speed back home. So there was no acceleration here. It just was like stopped and then constant speed running home, 2 minutes. So I do know a lot about that though, right? I do know that he was 500 meters away and it went down 500 meters in 2 minutes, right? So I can totally figure out the speed here, and it makes perfect sense, that part of the graph. I also know he's stopped for 1 minute here. That's part of the question. The only part about distance and times that's a little bit fuzzy is in here. So the textbook hopefully will be more descriptive in the information that they would like. So basically, how long did the total journey take? That's something where you need to kind of think about. In terms of like, what happened to the graph when he turned around and traveled home. It's a negative slope, right? It was all positive here, positive. It goes up 450 meters every 4 seconds. That's a positive slope. And then it's like, think of slope, dude, 0 fun, right? He's stopped here. Slope is 0. And then a negative slope is him returning home. And it's not like he's going negative speed. It's just like he's heading in the opposite direction. So you kind of need to think about, what his actual direction is. Maybe he got like a Xbox in the mail. So he walked there, and then once he saw he got his Xbox, he like was so pumped he just like ran home. I don't know. All right, so on that page 368, there should be some good questions in there to try those 3 there, so that you guys can actually be sufficient in what you've got in terms of practicing that and seeing and drawing the graphs. So we'll take these up tomorrow because, again, I think this was probably a botched lesson because of your lack of ability to take the notes and me to explain things as we go. But let's try these 3 questions in here, and then we'll take those up tomorrow, unless they were super easy, but I think we'll probably take them up. All right, guys, I'll be available in Teams. So anyways, hit me up in there if you have any questions. Sorry about already sending you the lesson that was totally filled out. It's a bit of a waste of time on my part, so sorry about that. Anyways, hope you guys have a great day. Thinking about you, and we will talk tomorrow. Awesome.